Hello everyone, welcome back to the pharmacy compounding series. Today we'll go over the solution because in compounding pharmacy, solution drugs is a majority part. So we already had a solution lab last week, but we are also going over some more solutions today. So like before, Haley will go over the solutions with the calculation and the lab method.
Hello everyone, it's Haley again, and today we have 3 more solutions prescriptions we'll be going over. So our first solution, you received a prescription for potassium gluconate solution to help with the patient's hypokalemia or low potassium level. You've received a prescription for potassium gluconate 10 milliequivalents per 15 ml, purified water 45 ml, and adding Ora-Plus or Surspend SF up to 60 milliliters total solution. So, your question is probably, how do we measure out milliequivalents? Well, we don't. So we need the molecular weight of potassium gluconate, which is about 234 milligrams per milliequivalent, so that we can determine the mass of potassium gluconate we can weigh out in order to obtain the 10 milliequivalents. But first, we need to recognize that the concentration asks for 10 milliequivalents per 15 mLs. However, we are making up to 60 mLs of solution. So we determine the total number of milliequivalents we need in our solution, which is going to give you 40 milliequivalents. Then we use the equation. So milligrams is equal to milliequivalents times our molecular weight over valence, which in the case of potassium gluconate is 1. So we know we need 40 milliequivalents multiplied by our 234 and divide by 1. This will give you the total mass of potassium gluconate you will need to weigh out in the solution, or 9,360 milligrams of potassium gluconate. You will weigh that out, dissolve it in 45 milliliters of purified water, our solvent, and then you will add up to the fill line of 60 milliliters of Ora-Plus or Surspend SF for flavor, as potassium gluconate has a bitter taste. You'll dispense it to the patient and let them know to look out for irregular heartbeats, muscle cramps, or shortness of breath. The second prescription today is for benzocaine topical for topical pain relief. The prescription reads for benzocaine 1%, benzethonium chloride 0.1% for preservative, alcohol 70%, and purified water up to 60 mL as co-solvents. So we'll approach this particular prescription in 3 parts. To determine the benzocaine we need to measure, we know that 1% weight per volume means that we have 1 gram per 100 milliliters of solution, multiplying by our total volume of 60 milliliters. That would give us 0.6 grams or 600 milligrams of benzocaine to measure out. This benzethonium chloride, 0.1%, this is also in weight per volume. However, we're given, or we have on hand, benzethonium chloride in liquid of 15 milligrams per 1 milliliter. So we will do the calculation the same way as our benzocaine. We will just convert back to milliliters at the end. So we can set this up by saying 0.1% is the same as 0.1 grams over 100 milliliters, multiplied by our total volume of 60 milliliters. Going to go ahead and convert back to milligrams. and then convert this to a volume by multiplying by the reciprocal of that concentration. So multiply by 1 milliliter per 15 milligrams. When we do this, our units should cancel out to leave us 4 milliliters of the benzethonium chloride solution. For the alcohol, we know we need 70% of this solution. However, on hand, we have alcohol 95%. So to find this, we're going to use a formula you may have remembered from general chemistry of C1 B1 equals C2 B2. We already know that our C1, or what we desire, is 70 times our volume 1 of 60 mils is equal to our C2 of 95 times our B2, which is what we are trying to solve for. Okay. So when we rearrange this, X will come out to 44.2 milliliters of alcohol to add to the solution. So you will dissolve your benzocaine, 600 milligrams, in your 44.2 milliliters of alcohol. The benzethonium chloride, you will collect 4 milliliters with a syringe and add it to solution. And then you'll add purified water up to 60 milliliters mark. You will then dispense it to the patient, letting them know it's for topical use only, to avoid the eyes, and to wash their hands after application. Our third and final prescription today is for a 15 milliliter solution of glycerin 6%. However, on hand in your pharmacy, you only have glycerin 10% and glycerin 4%. So how do we get 6%? You may remember from last lab, we introduced alligation method. That is exactly what we're going to use here. So remember, for alligation method, we set it up by placing the concentrations we have here. We put the concentration we want in the middle. And then we go diagonally down, subtracting the top number of what we have with what we want. So 10 minus 6 is 4. 4 minus 6, the absolute value of that is 2. If we add these two numbers together, we get the total number of parts for the solution. So we have 6 parts total. The numbers that are horizontally in line with the percentage we have represent their fraction of the total parts. So we need, of the 10% solution, 2 out of 6 parts of our total volume of 15 milliliters. This is equal to 1/3 of 15, or 5 milliliters. Then for the 4%, we need 4 out of the 6 parts of, again, multiplying by our total volume, which will give us 10 milliliters. If you're ever concerned, you could always recheck your work by adding your total volumes together, and they should add up to equal your total volume. So you will add 5 milliliters of 10% of your glycerin, 10 milliliters of 4% glycerin, and this will give you 15 milliliters of 6% volume by volume glycerin solution. You'll give it to your patient to help with their dry skin.